Okay, guys, so we're going to begin the class. Remember that you had an activity about the EICM software. Did you make it? Did you install the software and so on?
No.
Diana, why not? What happened with that activity?
I have forgot activity.
Okay.
I'm sorry.
Anybody did it? Martin?
Yes.
Yes, you did it? Yeah, and you have the software installed and so on?
Yeah.
Okay, very good. Can I have a show of hands in the participant pane on the Zoom? You can say yes, no, or thumbs up or thumbs down. If you made activity, can you show me that you did it? Okay, Florencia did it, Alejandra did it, Martin did it. Martin, Monica. Okay, so what we're going to do today is to review the part of the software, right? The software that you have to install, the IECM. So that software is particularly useful to see for, well, most of it for combustion, but you can use it for combined cycles and so on. But that part we're going to see it later on. Okay, today we're going to see the part of the burning coal, right? That was part of the activity. So let me put the software on the screen, and we can do a couple of things there. What is it? Okay, so you should have something similar to this part of the, well, this is the principal software. When you open it, you find interface like this one that let you save, well, start a new session or open a session, right? Or close the program. So if you press the new session, what you're going to find is it's going to ask you what kind of plant that you want. In this case, we're going to use pulverized coal, but you can use natural gas combined cycle or gasification combined cycle. Okay, we're going to use the pulverized coal this time around. So I'm going to cancel there because I had it open already. Okay, so the first thing that you have is this window, right? In this window, you have the new plant, and you don't have anything else. The only thing you have is a burner and a feed, right? And some control of the ashes. But you can see in this pane, in the configuration pane, that you can have the configuration. For example, there are many predetermined plants, but we're going to start with a new one, right? And you can have, well, for example, you can have a control of pollutants in the combustion or in the burner, right? In this case. So, for example, here the fuel type, the only one that we can choose is coal, of course, and we can ask for a NOx control, nitrous oxide control, right? In this case, we only have to not control it at all, or to use informals control, right? Informals control, if you remember the presentation that we did about burners, depends on the type of burner that you have. If it's mixing correctly the oxygen and the air, and if you have a return flue gas and so on, that's that kind of control, the NOx control. For the people that just arrived, please, if you need to ask something, just mute your microphone. Let me know, okay? I'm going to keep muted everybody, but if you need to ask a question or something like that, just let me know, right? Okay, so as I was telling, the NOx control is in that, but we have post-combustion control too. Okay, so we have different types for different pollutants. For example, the NOx control after the combustion, that it's called a hot side SCR. Okay, mercury we can control it with carbon injection. Particulates, that it's suspended particles of small size, very bad for the lungs, for example. You can control it with two different things, with cold-sided ESP, it's electro, I forget the name right now, or the fabric filter, right? And we need to have a control for the sulfur oxide and carbon dioxide. Okay, so we have wet FGD or lime spray dryer, but that is only an option. For CO2, we have many different kind of controls, right? Amine control, ammonia system, membrane system, and so on, right? I'm not going to go in deep in these controls because that's part of an activity that you're going to do this week, okay? And the last part is the water and solid management, okay? So for example, the cooling system could be using a stream of water, for example, of a river. That is the one slough, right? And if you see in this upper part of the diagram, we have a yellow heat exchanger, right? And the water goes in and goes out and returns to the river, for example, right? But many times that's not an option. So we have, for example, a cooling tower. That's more efficient, ecologically speaking. But if you have a river and you're not going to change too much the temperature of that particular water, you can return it. Then you have air-cooled condenser, that, as the name implies, uses air to cool the water, well, to cool the stream and to condense the water. And then we have the hybrid cooling system that uses a combination of both, right? Uses air to cool down the water vapor, and uses a cooling tower, right? We're going to keep it in one slew for this time around. And then we have the wastewater. What do we do with the wastewater? In this case, it's treated just as an ash pond. In that case, we only throw it into a pond, and in that one, we wait for it to sediment and so on to use it again as a gray water. But we can have a more sophisticated treatment, for example, a chemical treatment or a mechanical treatment. In those cases, well, it's more or less like the treatment plant that we have at IECM, right? If you have seen that one, it's more or less like that one, right? It has mechanical treatment, there's filters and sedimentation, and chemical treatment to treat biological waste and so on. Okay, and then the fly ash disposal. That is well, as the name implies, is the ash that is floating in the air, or but not in the air of the fume hood. No, it's in this case is the ashes near the water that goes in the bottom part of the burner. Okay, so if you have any questions, let me know. Right. Right now we're going to see. I'm going to choose a couple of these post-combustion controls. For example, for NOxes, I'm going to add a hot side SCR. For the CO2 capture, I'm going to ask for an amine system, right? Just to have a couple of those. Okay, so that's if you go to the left side of the software, you're going to find the configure session, right? And there is the plant design that is choosing the different controls that we want or that we don't want, right? The plant location let you have predefined values, well, predefined modifiers. If you have this plant in any of these regions, right? You can choose other region, and you have to change those values. We're not going to go in that right now because it doesn't matter that much. Okay, and then the unit systems. If you want to use it here in Mexico, of course you're going to choose the metric system, the default unit system. The session, or in this case, we have metric, and the results is going to be in hourly, all right, each hour. Okay, so that's the configure session. So if we go into the left pane, we go to the set parameters. We're going to have, it depends on the amount of controls that we choose in the plant design. We're going to have, well, different panes, right? In this case, we have a list of overall plant, fuel, base plant, in NOx's control, CO2 control, byproduct management, and water life cycle assessment, right? So the diagram is, well, the one we choose already, so we don't have a change in that one, but we can change in the performance, for example. In the performance, we can ask for, or we can change a couple of values, right? For example, the ambient air temperature, the dry bulb average temperature. For example, here in Mexico City, we are around, let's say, 25 degrees, right? The ambient pressure, the ambient pressure, it's in megapascals. So right now it's in atmospheric pressure, right? So we can change it a little bit, but not as high as Mexico City. If you see here in the columns, in the left pane, we have a minimum value, a maximum value, and the default value, right? So the minimum value is 0.082 megapascals, right? In Mexico City, it's a little bit lower than that one, but we can choose that one instead, right? So I'm going to write down those values, right? And that's it, right? And the relative humidity, well, depends on the place again that you are. In this case, Mexico City is around 50–55%, depends on the season of the year, of course. But right now it's around 55, so we're going to leave it in 50, right? Those are the values, well, more or less what we want to expect, right? For example, this particular plant, it has a gross electrical output of 600 megawatts, right? The capacity factor, we're not going to change that one, okay? It's more or less a nominal efficiency that is difficult to assess without a pilot plant, okay? So we're going to leave it in 80. And then we can change a couple of things. For example, here in the overall plant, those are the nominal values that we have to change. For example, here after the performance, we have the region-specific cost factors. Okay, so we could change those values if we need information. For our class, we're not going to use that part, the part of the costs or the regulations. Okay, but you could add it. Okay, you could change, for example, if you have different normativity or standards, you can change it in regulation and taxes, for example. You can add the maximum and minimum values that you need, for example, for sulfur dioxide emissions or for nitrogen oxide or particulates and so on, right? We're not going to use those right now. Okay, so I'm going to change to the fuel tab. It's over here. So there you have coal properties, right? Okay. So in the coal properties, what you need to, well, you can choose a type of carbon. If you click here to retrieve a coal from the database, right upper side, you can choose from a database. You can choose different coals. If you see here, we have selected Appalachian low sulfur, right? But we can change that one, right? Right now, it doesn't matter which one we choose because we're only playing a little bit with the software. But you could add a new one too, right? You could create a new coal, and well, it's going to ask you for a couple of values. For example, the heating value in BTUs per pound, or the carbon, or the percentage of weight of carbon, hydrogen, oxygen, chlorine, sulfur, nitrogen, ashes that they don't combust, moisture if the coal has moisture that most of them have, if you have the cost per ton of it, right? So of course all these percentages should sum some 100 of course. So we're going to leave it in Appalachian low sulfur, but you could use it for different biomass. For example, if you remember the first exam that we did, you had different biomasses, so you could put the values of that biomass in here, and you could have a very good estimate on what should happen if you burn that kind of biomass, right? The kind of pollutants that would be produced and so on. Okay, so it's really useful. It's a good model to use. Okay, so I'm going to leave it in Appalachian low sulfur right now. Okay, so we have the values, right? And then we have in the left pane we have ash property. Yes. Anybody wants to ask something? No? Okay. So in the ash properties, well, it's the components that the ashes has. Well, so for example, silicon dioxide or aluminum trioxide or iron oxide or calcium oxide or magnesium and so on, right? This is important for regulations about different metals that the fumes can have, right? So if you don't know this information, it doesn't matter for the things we're going to do, right? In this case, so you could leave all that in zero, for example, and you could have nothing in the ashes, okay? Then many times we use an auxiliary gas for example, for the beginning of the ignition, or if you have a biomass or a coal, you need to start the reaction, right? So many times we use an auxiliary gas, and that gas can be, well, many times we use natural gas or LP gas, right? So you should use the values for each one. In this case is almost pure methane, right? 93% of methane, but you can change that if you want to, right? Mercury, well, it's more or less the amount of mercury in the coal. If you have the determination in the coal or in the biomass, well, you can put that value in, right? In this case, particles per million in the weight, right? For one pound, well, in this kilogram, right? That's it, right? If you have the costs of the auxiliary gas and the coal, well, you can put it in there, so you can have an estimate on the costs of using this particular plant, right? There, if we change to base plant, you're going to see that we have the different parts of the plant. For example, the boiler, the air preheater, the base plant performance, the steam cycle performance, furnace factors, capital cost, operation and manufacturer costs, and retrofit are just factors that we are not going to see that part, right? So if you see here in the boiler diagram, we have a couple of things, right? For example, we have the fuel in and the mercury in, because the mercury is going to go with the fuel, right? We have heated air in that we preheated, right? And then we have the water that is going to the water that we're going to heat, so we can have a vapor, right? A stream of vapor that we can use to generate electricity, for example, right? And then the flue gas is going to go out with the mercury and the fly ash too, of course, right? In the bottom part, the ash, part of the ashes and the solids of the coal, they're going to go out with the wet bottom ash, because we're going to combine it with a little bit of water, right? So the next step in the left pane, that is the air preheater diagram. Well, we have what we're going to do with the air, right? We're going to preheat it with the exchanging heat with the flue gas, with the current of the flue gases that have fly ash and mercury too, right? This is just exchange of heat. It's not going to exchange mass, right? In this case, and we can have here in the performance, we have the different values that we're going to use, right? So, for example, we have, right? Wait a second. Let me see, somebody is asking me something in the chat. A second. Okay, so no, maybe it was another thing. Okay, so here we can change the values that we want, for example, in this particular plant. Okay, so here in the first part of the upper pane, on the right, you have the gross electrical output, right? That's the amount of electricity that you want to generate. The plant, you want to design that plant to have a gross electrical output of 600 megawatts, right? The unit type, we have 3 different settings. We have subcritical, supercritical, ultra supercritical, right? That's how we want to heat the water vapor, right? Subcritical would be well, water that has a temperature, well, not a very high temperature. For example, for domestic use could be that kind of thing, right? But if you have a plant to generate electricity, what you need is either to use a supercritical or ultra supercritical, right? So the state of the water vapor, it's in the right side, well, of the, if you remember a phase diagram, you're going to have higher temperatures, so you're not going to be able to distinguish between vapor and a gas, right? So that is supercritical. And ultra supercritical, well, it's a lot higher than that, right? So you make a vapor that has a very high temperature, so you can use it to propel a gas turbine, for example, right? Okay, so the steam cycle heat rate is the amount of energy that we want to transfer to the water. The boiling Fahrenheit type is, well, depends on what you use in tangential. What it does is that burns in an angle, let's say like that. In the wall is the kind of things that we saw in the video a couple of weeks ago. And in cyclone, well, it mixes with air, but swirling the air and the gas, well, and the coal, the pulverized coal in this case, right? The boiler efficiency, well, that one can be, if you see, you have a column that says calc, that is that the model is going to calculate it, right? So that's the efficiency that the boiler should have, right? If you know the efficiency of your particular boiler, you can unmark this column and change it. Let's say that it's 85% the efficiency of the boiler, right? So that is going to change, of course, the efficiency of the whole plant, right? And then you can put as the excess air you want to put, and how much air you want to exchange in the preheater diagram. Here on the right, you can see that it has a leakage air, right? That one is because you're recycling the flue gases, so you don't want all the gases to get into the boiler again. So you don't recycle everything. So you have a leakage air there, that you can change here, percentage that you want to send outside of the boiler instead of recycling it, right? Then we have gas temperature in the economizer. The economizer is what? See, is well, it doesn't seem, it doesn't appear in this diagram. It's after the heating, after the heat exchange, we have that part, right? So those are kind of the values that you can change, right? Here you have a value that it's to treat the sulfur oxide, that it's called a hydrated lime for SO3 removal, right? We are not using it right now. You see, if we didn't choose any SO2 control, right? So that is not going to change anything. And then the base plant for requirement. To pulverize the coal, we need a certain amount of energy. To have the steam pumped, we need a pump, right? So we need to spend a little bit of the energy and so on, right? So here you can change the amount of energy that it's going to take, but it's going to be calculated in the model, so you don't have to change anything there. Okay, but what I mean is that you don't have to change anything, but you are going to find that you need energy to treat the waste, for example, or to pulverize the coal, or to pump the steam, and so on, right? So that's part of the results that we're going to find later on. Then we have the steam cycle performance. I'm not going to spend much in here. We have a boiler, we have a condenser, and we have water to cool it down. Well, to cool down part of it, and then to use it for energy in the other part, right? You have a steam turbine here, so to produce to produce energy, right? And it's going to go through the boiler again, well, because it needs to go to the boiler to produce vapor, to produce the water vapor, and that steam, well, it goes to the turbine and it makes energy, right? Well, let's leave that for a minute, and then we go to the NOx control. If you see the NOx control, we choose two different controls in furnace control and a hot side SCR control. Okay, so here you have what it does. It refluxes from part of the flue gases. Here's the current in the upper part of the diagram. So the flue gases they maintain the temperature inside of the furnace or the boiler, so it doesn't go too hot. If you have a very high temperature around 2100 Celsius, you're going to start producing NOxes. Okay, so in this case, if you do that, you reduce the temperature inside of the boiler, and you prevent for the NOxes to be formed, right? But if you need high temperatures, you're going to produce NOxes either way. So that's why we have then a hot site SCR, right? In this case, it's going to treat the NOxes with ammonia and water vapor. Okay, I'm not going to go deep into that one because you have to research it for an activity that we're going to do. But we Okay, let me see. I think we have it on again. Can you hear me again? Okay. Yeah, my microphone went out. I don't know why. Can anybody tell me more or less what was the last that you heard? Because I'm not sure. Diana, can you tell me what was the last thing that you heard, please?
I think about the. Can you see your screen?
Just wait a second. Let me share it again.
In the part of config after before performance, I think.
Before performance of the hot side as SCR?
No, before.
So in the base plant performance?
I think it was the NOx control, I think.
The in-furnace control.
Yeah.
Okay, so I will pick it up from there. Thank you, guys. Okay, so what was I saying is that we choose two different controls for the NOxes. So we choose an in-furnace control that we saw in the video, for example. We saw on the video, and on the video, if you remember, we saw that you have a mix of a mix of the air and the fuel in this case, right? So what we have, it's a mixing, and that is part of it, and the other part is the flue gas recirculation that you can see on the upper part of the right pane in the diagram. You can see that there is a blue line that goes again, that recycles, right, the gases. That recycles, what prevents is for the temperature to rise too high, right? The temperature, it's maintained below, let's say, 2000 Celsius. You're not going to produce any NOxes, right? The only problem is that if you don't have a very high temperature, of course, you're not going to be able to produce steam with enough energy, right? So you tune up the control so you can have a highest temperature that you can, but with the lowest NOxes. And if you need a very high temperature inside of the boiler, you can use a hot side SCR, right? So in these two controls, in the performance pane, you can change the maximum removal efficiency of the NOx process. That depends most of the time on the manufacturer that makes the part, right? Many manufacturers reach around 50, it's nominal, but you can have 70, 80% in furnace control, depends on what you're using it, right? So the maximum NOx removal efficiency is one that you're going to choose, right? Let's say 50%, and the actual NOx removal, well, it's going to be determined, depends on the parameters that you're choosing. Then in the hot side SCR, it's a chemical treatment, right? So you use ammonia and steam to treat the flue gases. I'm not going to go in deep in this particular one because we're going to research it for an activity that we're going to do in this week, right? But you can change the number of trains, that is the number of chemical steps, let's say that like that, and the number of catalyst layers, and so on, right? You can change many. You can change many properties of this particular one because it's kind of complicated, right? And of course, you have a capital cost for the energy, for the reagents that you need, and so on, right? So then if we go to CO2 capture, we have a CO2 absorber and an SO2 absorber. You're going to research these two, so we're not going to go in deep for it. But you can change the performance of each system that you choose, or of each control that you choose, right? That's why the activity that we're going to do this week is pretty important for it's pretty important for example, to choose exactly which strain of treatment that you're going to be able to choose, right? So I'm not going to talk more about all these different systems or different controls, and I'm going to go to the results, right? In the left pane, you can go to the results, right? Let me write this down, and again, you have the overall diagram, and then you have the plant performance, right? So here in the performance parameter in the left table, you have the net electrical output, so the amount of electricity that you generated, right? That electricity is, well, the electricity that you can use for other things, for example, to power up a city or a town or that kind of things, right? Here you have the primary field input, the auxiliary field input, the amount that you see that we are not using any of it, right? The coal that we choose it has enough energy to obtain all the electrical power that we needed, right? The gross plant heat rate, we have the net plant heat rate, the annual operation hours, that it's the whole year, annual power generation, and so on, right? And net plant efficiency, that's around 33%, right? So in the right pane, in the right table, you have the plant electricity requirement, right? So the gross electrical output is 600 as we choose it to be, right? But what it changes is that of those 600 megawatts, you're using part of the power or the electricity to power up all the pollutant controls, for example, all the pumps, all the pulverization of the coal, and so on, right? So that's why you have a base plant use that is 23.07 megawatts. The hot side SCR uses, again, power, that is 3.92 megawatts, and the CO2 capture system uses energy too, right? So of all those 600, you end up with 522, right, megawatts. Okay, so this is the plant performance, and you can have in the left pane, you can search for mass in and out. So you can have the metric tons of each of the fuel, the lines. In this case that you would choose the CO2 control for ammonia, you can have the amount of ammonia that you need, right? And other chemicals that, in this case, because the plant that we choose, we don't have them, like urea or the basic acid and so on, right? So you have all the chemicals that you need, 0.46 tons per hour, the activated carbon that you need, the total water that you need, it's, well, a lot, 4,000 tons per hour, and the water to replete in the system, right? And in the right table, you have the solids and liquid outputs. Okay, so that's all the things that is produced in this particular plant. So we have the bottom ash disposed, that it's 2 tons, well, 2.7 tons per hour. Or we have discovered solids deposit, the particle emissions, the CO2, and so on, right? Or you have the table there, right? And you can have the solid in and solid out, depends on the treatments that you have. And if you see, you have in the different columns, you have the different parts of the plant, right? The bottom ash, the combustion zone, the post-combustion zone, the economizer, the SCR, and so on. Depends on all the systems that you choose, well, what you are going to have there, right? The amine scrubber, the auxiliary boiler stack, the main stack, and so on. You have all there, okay? And what else? You have the total costs. Remember that all these costs are costs in US dollars and are from 2014, right? But it's a good measure on more or less how much it costs to have a plant, a pulverized coal plant, right? You can have the cost summaries and that kind of things, right? Here in the fuel, you have the amount of well, the composition of the coal that you're using and the auxiliary gas. You have the base plant, you have the diagram, you have the flue gas, that is, well, the part that we should treat, the capital cost, the air preheater, and so on. Each one of those systems, you can see how they perform and what is the the temperatures, the amount, the mass you need, and so on and so forth, right? So one part that is very important in this particular software is the analysis tools. The analysis tools, you can find them in the bottom part of the left pane, right? And there you can choose different independent variables. The independent variables is the variable that you want to modify to see how another variable or another variables changes, right? So in this case, for example, if you ask yourself, what happens if, for example, if I have a different temperature in the preheater, for example, or what about how the performance of the plant changes if we have a different relative humidity? Let's choose this one for a second, right? So if I choose the relative humidity, I'm going to select that parameter, right? And here in the lower part, you can change the values, right? So for example, independent variable configuration, type of variation, we can ask for a range, a change in the range, right? So for example, let's say that we have 10 different points, and we say, okay, the minimum value in Mexico City, let's say that it's 25%, and the maximum value, let's say that is 85%, right? So the independent variable is going to change in these steps, 25, 31.67, and so on, right, until 85.0, right? So we're going to use the selected parameter in the upper right part, okay? So we select that variable, and then we choose the dependent variables that we want to plot. Here it calculated all the data, so we only have to choose what results we want, okay? So if we go to the overall, to the get results and then overall plant, we can see, for example, the net electrical output, right? That is the electricity that we can use to perform other tasks. If you see the table, we have the independent variables. There is the relative humidity, and then we have the net electrical output. If you see, the humidity doesn't change almost nothing about the net electrical output, right, in the megawatts. It's still the highest electrical output is 522.7, and the lowest is 522.4. So it's a negligible result, right? So we can say that the relative humidity doesn't change anything about the electrical output, right? But you can see, for example, the net plant efficiency. The net plant efficiency reduces just a tiny niche, so the relative humidity doesn't matter, more or less, right? But what about if we choose another parameter? Let's say choose independent variable again, and we're going to change, for example, let's see, overall plant performance. No, we're going to change to the base plant. Okay, so to the base plant, we're going to change and the gas. The gas in the temperature exiting the air preheater, right? So we're going to select that parameter, and we're going to start from 0 to 100. Select this parameter, and the lowest value is 65.56 Celsius, and the highest is 260. So let's see what happens if we have all the range, right? And we're going to add 20 different points, so we have more data. Okay, so again, let's see, 20. And then we choose a dependent variable. So the dependent variable, again, we go to the get results and then overall plant. And then we go, for example, for the net electrical output value, right? So if you choose to have a higher temperature in the preheater, you're going to use energy for that particular, to heat the air. So you're going to spend more energy preheating the air, right? So the net electrical output is going to change from, if you used a cold temperature, let's say 65 Celsius, you're going to have 524 megawatts, right? But if you go to 260, you're going to have, well, it is not too much. It's not much for megawatts, but you have to take that into consideration, right? The net plant efficiency is going to drop 0.2%, right? So it doesn't matter that much. But in an activity that we're going to do further on, you're going to change the different values to see how you could optimize your plant performance. Okay, so that is for this part of the class. I don't know if you have any questions about the software. If you don't have it installed already, please do, because we're going to use it for the exam at least. Okay, for the second partial, we're going to use the software. So I need you to have it, right? So I don't know if you have any questions, if you want to unmute your microphone and ask for a question, or in the chat, or whatever you want, right? Nope. So no questions at all. Okay, so Florence, yeah.
No tiene micrófono.
Yo tengo pregunta. ¿Qué? Ya ves que en el tutorial del PDF no tenía como que cooling system. ¿Eso es normal? O sea, era en las...
¿En qué?
O sea, es que en el tutorial del case study que íbamos a hacer, como que la planta no tenía la parte, no sé, no salía. Entonces...
Ok, this part of cooling system?
Ajá, o sea, bueno, no sé si ahí, pero en la figurita no salía toda la parte amarilla. Pero no importa, ¿no?
No particularmente. Pero sí, o sea, está bien que, o sea, que lo notes, ¿no? O sea, se me hace raro que no estuviera. Déjame ver un segundo, tenía por aquí el que dice. En efecto. No lo tengo puesto. Sí, bueno, pues es que sí lo han modificado bastante, bastante el programa en las últimas versiones, y no han actualizado justamente la parte tutorial, ¿no? ¿Sí? Pero bueno.
Y de esa actividad que todavía podemos enviártela.
Pues sí.
Bueno.
No tendrán 100, pero sí me la pueden mandar.
Ok.
Va. Another question or anything?
Yo tengo una duda. Ahorita acabo de abrir mi programa.
Ajá.
Y no sé por qué no tengo la parte de NOx Control ni la de CO2 Capture. ¿Tengo que picarle algo en especial para que salga?
Pero sí seleccionaste, cuando pusiste nuevo, sí pusiste que fuera un Fulbright Code.
Sí, y no me salió. Entonces no sé si es que descargué como otra versión que no creo, o no sé por qué no está.
Pues hasta arriba del lado izquierdo puedes ver qué versión tienes.
Es la 9.5, ¿no? Sí, es la misma y no me sale eso.
Y aquí en configuración no tienes nada seleccionado en la parte de derecha donde despliega un menú.
No. No, porque justo en esta parte de... no sé, la acabas de quitar, pero ahí no tenía nada de eso.
Ok, estaba puesto en No Devices.
A ver. Ahora sí, ahorita le pico, estoy seguro tiene que salir, ¿verdad?
Pues sí, debería ser.
Ok.
Pero bueno, si no lo logras, pues me comentas para que lo veamos, ¿no?
Ok, sí.
Vale. ¿Alguna otra pregunta por el momento? Gerardo preguntó que si íbamos a hacer alguna otra práctica con este programa. Sí. O sea, les voy a dejar una actividad la próxima semana y pues en el examen también lo van a tener que usar un poco. Gerardo también me preguntó que si había en otro lugar donde hubieran otros casos de estudio. En la misma página, en la página del programa, tiene algunos tutoriales y tiene algunas otras cosas de interés por ahí. Y no sé si alguien más tenga alguna otra pregunta. Ok. Bueno, les subí una actividad. Bueno, let me change to this again. So I uploaded an activity to Blackboard that should be there. That we're going to do pollutant treatment. That is activity 9. It's called pollutant treatment. Okay, so we're going to do a wiki about how to treat this these pollutants, right? The flue gas pollutants. So the main pollutants. Let me put a notate here. So the main pollutants is the carbon monoxide, carbon dioxide, mercury, lead, NOxes, SOxes, and suspended particles, right? So we are going to do a wiki about that one, okay? So let me open the Blackboard so you can see where to use it, okay? All right. So here you go to, in the left pane, to activities. In the activities, you're going to find an activity that is treatment of air pollutants, right? And it has the same information. It says, in all industrial processes, it is of utmost importance to control the class of pollutants emanating into the atmosphere. In the process in which we have focused on this course, the main pollutants of the flue gases are CO, CO2, mercury, lead, NOxes, SOxes, well, nitrogen oxides, sulfur oxides, and suspended particles. So in this activity, you will prepare a wiki that it's, well, more or less like a Wikipedia article, right, about the treatment of the different pollutants. We're going to have teams of 2 and 3, and each team will oversee one of the pollutants, okay? But all have to participate in the other sections of the wiki. So let's say that I have to work on, I don't know, carbon monoxide. So I do the wiki of carbon monoxide, but I have to read and participate in the other sections, right? In mercury and in lead and so on, right? The grade then will consist on 70% on the information of your particular section and 30% on the contributions you made in other sections, okay? For each pollutant, the minimum required information, if you want to add more, it's fine, but it's not required. You need to put the physical properties of the pollutant, the chemical properties, especially atmospheric reaction that can occur with it, main health risks, and the type of treatment that you can have, right? If you use the basic treatments that you have in the IECM, that could be good, right? You need to put the main characteristics of each process, advantages and disadvantages, and principal costs, right? That will be one part of the activity, and to make sure that everybody knows and read the wiki, you're going to write here. It's over here, right? The last step is to write a brief document individually where you describe what kind of treatment would you choose and why, okay? And those assignments can be found in Blackboard. Here is activity 9, selection of treatment plan, right? So this wiki is for the whole week, so you have to finish it for next Monday. Okay, and we're not going to have a Zoom class on Thursday. Okay, so I want you to have a very good wiki about how to treat the pollutants, right? So if you go into the treatment of air pollutants, you're going to find a page that is this one. Okay, so if you see in the right side of the screen, you have a section for each of the pollutants, right? Carbon monoxide, carbon dioxide, lead, mercury, nitrogen oxide, sulfur oxides, and suspended particles. Okay, so if you pick one of those, you can edit the wiki content and add add the information that you want. Okay, you can write it down in, for example, in Word, and then paste it in this content pane, right? You can add images or videos or whatever you want to add into the wiki. It's fine, right? And that's pretty much right of the activity that you have to make. It's very important to treat the contaminants or the pollutants, and of course each country has their own standards or normativity about it, right? Mexico is not one of them, how to say it, well, they don't care too much about the contaminants. Well, in Mexico City, yes, but not in all the states. But in the US and in Europe, they have a pretty tight control of contaminants, right? And they have fines about, well, if you overpollute, you're going to pay top dollar for it, right? Okay, so that's the activity. That's the activity that you have to do. This is for Monday, for next Monday. And the other part, of the activity 9, that is the train of the treatment plan. It's for Thursday, for not this Thursday, next Thursday, right? So you have to read more or less all the wiki, so you can choose a treatment treatment plan that is logical, of course, right? So that's it for this class. I don't know if you have any questions about the software or any questions about the activity that you have for this week. Okay, next week we're going to start with the gasification. Well, not gasification, more liquid. How to produce liquid fuels using biomass, for example. Okay, so that is for today. I don't know if you have any questions or anything to discuss.
Yo, profe.
Sí, Diana.
Dijo algo de que el otro jueves había que entregar la segunda parte del wiki, o cómo fue eso, no lo entendí.
Es que tiene dos partes. Una parte es el wiki, ¿no?
Ajá.
Es todos los temas de los diferentes contaminantes. Eso es para el próximo lunes.
Para el lunes, sí.
Eso es, déjame ver un segundito. Eso es lunes 16. Y entonces, ya que todos acabaron su parte del wiki, cada quien, eso sí, individualmente, tienen que hacer un plan de tratamiento de gases contaminantes. Entonces, de las diferentes técnicas que hay para tratar los contaminantes, para cada uno de los contaminantes, pues seleccionar cuáles usarían ustedes y por qué, ¿no? Eso es para el jueves 12.
Pero esa selección de tratamiento, o sea, ¿a partir de qué lo podemos seleccionar o nada más como...?
Pues en este caso es muy general, ¿no? O sea, sí, en este caso es bastante general. Yo básicamente para lo que quiero esa actividad, esto es para asegurarme que ustedes conocen tratamientos.
Ok.
¿Sí? O sea, no tiene que ser un caso en particular, ¿no?
Okay. Entonces serían los mismos contaminantes que pusiéramos en el wiki.
Exacto.
Ok.
¿Cómo tratar cada uno de los contaminantes? ¿Qué seleccionarías para tratar cada uno?
¿Hay algún mínimo de contaminante?
¿Cómo? O sea, no, tienes que seleccionar, digamos, un tipo de tratamiento para cada contaminante. Entonces, uno para el monóxido, uno
para el wiki tenemos que poner los contaminantes, pero ¿tenemos que poner todos o solamente, no sé, 3 o 5, no sé cuántos?
No, más bien es cuántos tratamientos será. O sea, los contaminantes son los que están en el wiki, que, déjame lo comparto de nuevo, un segundito. Tienes esto, ¿no? Entonces, los contaminantes son todos esos, ¿no? O sea, tienen que hacer un wiki que incluya todos los contaminantes. Monóxido de carbono, etcétera. Entonces, para cada uno hay hay diferentes técnicas para tratarlos, ¿no? Para eliminarlos. Entonces, pues para cada uno poner los que mejor les parezcan, bueno, o al menos poner de menos los que vienen en el programa, ¿no? En el IECM.
Ok.
¿Sí?
Sí.
Y ya ustedes en la actividad que tienen que entregar el jueves, pues seleccionan cuáles de cada uno de ellos seleccionarían y por qué, ¿no?
Ok.
¿Sí? ¿Alguna otra pregunta, alguien?
Yo.
Sí.
Entonces, para el wiki, ¿cada equipo hace solo de un contaminante o de todos los contaminantes?
O sea, principalmente de un contaminante, ¿sí? Entonces, ahí sí creo que le preferiría que ustedes se pongan de acuerdo en cómo hacen los equipos y cómo se dividen, porque ahorita está un poco complicado a través de Zoom ponernos de acuerdo quién hace qué, ¿no? Pero entonces, cada equipo de 2 o 3 tiene que hacer un contaminante en particular, o sea, esencialmente un contaminante. Pero igual cada individuo tiene que cooperar a los demás contaminantes. ya sea con comentarios o con agregar información y demás. Eso yo puedo ver quién cooperó en cada cosa, entonces eso no se preocupen.
Ok.
¿Sí? Pero entonces, sí, si ustedes se pueden poner de acuerdo, que tienen su grupo de WhatsApp, creo, y hacen igual, pues me ahorrarían un problema.
Ok.
¿Sí?
Gracias.
Natán, ¿alguna otra pregunta, chicos?
Yo ahorita acabo de entrar a Blackboard y todavía no se puede entrar a la wiki, ¿es normal?
Pues ya debería estar habilitada hasta donde yo la había puesto, pero si no, ahorita la activo en este instante. Si no estaba.
Sí, porque le pico y dice wiki content not available. Entonces, o sea, en vez de entregar como un documento de Word, subimos directo la información a la wiki, ¿no?
Exacto. Sí, sí.
Y ya cuando sea seleccionar el tratamiento es cuando sí enviamos el documento de Word.
Exactamente. Y ahí lo suben,
Okay.
lo suben a través de la plataforma, ¿no? Ahí ya está. Ok, ahorita veo lo de que no está abierto. En teoría lo debería haber abierto, pero dame un segundito y ahorita lo checo.
Ok.
Vale. Bueno, no sé si tengan alguna otra duda entonces. Ahorita corrijo eso del wiki que no está funcionando bien. Ahorita lo corrijo. ¿Alguna otra pregunta? Bueno, aquí Rui me pregunta que si todas las entregas y las fechas están en Blackboard. Sí, bueno, pues ahí están las actividades y de ahí tiene su fecha cada una, ¿no? De entrega y demás. Bueno, chicos, bueno, eso es todo por hoy. Todas las clases que tengan, todas las interacciones que tengamos aquí a través de Zoom, las está grabando. Entonces, lo que voy a hacer es, bueno, pues cuando ahorita que la acabe de grabar, bueno, la subo a YouTube y les pongo un link en el Blackboard para que la puedan ver si es que lo necesitan, ¿ok? Y entonces, bueno, pues vernos por Zoom, nos vemos el lunes que viene. Recuerden que también estoy en las asesorías que están puestas en su syllabus update que les puse en Blackboard, que son miércoles y jueves. Ahorita no me acuerdo exactamente de las horas, pero bueno, estaré aquí en Zoom, la misma liga de siempre, la misma liga para todas las sesiones. Entonces, si tienen alguna duda o cualquier cosa, pues por ahí estaré, ¿no? ¿Vale? Entonces, pues clase presencial, digamos, clase a través de Zoom el jueves no hay, sino que nos vemos hasta el lunes. Entonces, bueno, pues eso.
Gracias, prof.
Bueno, chicos, hasta el lunes.
Gracias, Rodrigo.
Nos vemos.
Gracias, prof. Bye.
De nada, bye, que os vaya bien.